Hi, this is Miss Park, and this video is going to show how to graph quadratic relations or a parabola when the equation is given in the form y equals a bracket x minus r close bracket x minus s close bracket. So I will write it down for you so you can see, but for now I've opened Desmos. I'm going to type in an equation like that. So I'm going to go y equals, and then I'll give some number, let's say 2, open bracket, x minus 1, close bracket, x minus 5. Okay, so let's see what that looks like, close bracket. So you see I have a parabola. The 2 indicates the stretch factor. So this parabola has been stretched by a factor of 2. And the 2 is positive, which means the parabola is going to open upwards. But the purpose of this special way of writing the equation of the parabola is that the 1 and the 5 are significant. If you look at the graph, and I'll actually zoom in a little bit so you can see it, you see where the 1 and the 5 are. 1 and 5 are the x-intercepts of the parabola. Okay, so when we write a equation like in this form, it's actually called factored form. Those two numbers in the bracket will give you the x-intercepts. I'm also going to do another one. I'll make the y negative this time. Okay, and maybe I'll even make it a fraction. Okay, 1/4. All right, and I'm going to put inside x minus 3. And then maybe I'll put an x plus something. And what do you think it means if I put an x plus a number? Let's go x plus 1. So let's look at this parabola very closely. Okay, so the blue parabola it opens downwards because my a is negative. The 1/4 means it's been compressed vertically, or we say it's been stretched vertically by a factor of 1/4. This parabola is not going to be as narrow as the red one over here. Okay, it's going to be wider because it's not growing as quickly. And then the x-intercepts, you can see from the equation, one of them should be 3. And sure enough, we see an x-intercept of 3. The other x-intercept is at -1. So when the equation has x minus, like the red one, that number is where the x-intercept is. But x plus means the same as x minus -1. So that tells us that the x-intercepts are 3 and -1. All right, let's do a little bit of practice. So this, we can see how Desmos will graph it, but how will we graph it by hand? So let's see. I'm going to do just a basic sketch. Okay, so I'm just going to do this. All right, and let's give an example. So let's say y, so example, y equals 2x plus 3 and x minus 7. Okay, so our step number 1 is to look at this equation and go, what are the x-intercepts? All right, so I can see the x-intercepts right out of the equation. And remember, the equation is x minus r, x minus s. So that means the x-intercepts are -3 and 7. So in brackets, I'll just write over here, r equals -3 and s equals +7. Okay, x minus r, x minus s. Once I have those two x-intercepts, I can put them on the graph. So I'll put this one over here and this one over here. Okay, if you had a grid, you would do it nicely. Here, I'm just estimating. And I have now 2 points, which is great, except that I can't draw a parabola through 2 points because there's infinitely many parabolas that go through these two. I can make like a tall one, a short one, an upside down one. So that's not enough information. So what we're going to need now is to find the vertex. Right? So we know, because of the symmetry of the parabola, that the vertex is going to sit exactly halfway between the two x-intercepts. In fact, there's going to be an axis of symmetry that runs right in between the two of them. Let's figure out what that axis of symmetry is. Okay, so the axis of symmetry is exactly halfway between the two x-intercepts. And to get a number that's halfway between two other numbers, you do the average of the two numbers. So we're going to do an average. And what I'm going to do is I'm going to take my two x-intercepts. I'm going to add them together and divide by 2. And that's going to give me +4 over 2, which is +2. So my axis of symmetry goes through here, goes through 2. So that tells me that my vertex is going to be 2 something because the vertex always sits right on the axis of symmetry. So if my vertex is 2 something, it might be 2 something up here, or it could be 2 something down below. How do we know if the vertex will be up above or down below? So the way we know is we're going to look at this a value. The a value is a 2, which tells me that the parabola opens upward, which means that my vertex is actually going to be down below 2 something, so that the parabola can open upward. Okay, but to what? Right, so this is where we use the equation. We'll sub x equals 2 into the equation to figure out the matching y. And we get y equals 2 times 2 plus 3 times 2 minus 7. That's 2 times 5 times negative 5. That's 10 times negative 5, which is negative 50. So my vertex, okay, so I've drawn it a little bit high. Let's go a little lower. I don't have a scale really, but I can draw it a little bit lower just to illustrate. So let's go much, 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 much lower, negative 50. Okay, and so here's my vertex. My vertex is at 2, negative 50. Okay, so I now have 3 points. Okay, which is really nice. I got 3 points. Now a true sketch, so I'm going to write over here, therefore the vertex is 2, negative 50. A true sketch should really have 5 points. So how can I get more points? Well, something that we're not really used to working with, maybe a little bit with lines, is the y-intercept. Y-intercept is a really easy point to get, because to get a y-intercept, we know y-intercept sits on the y-axis, so we know that the y-intercept is some point 0 something, the y-intercept. So if I want another point, I can take my equation and figure out the y-intercept. So I'm going to go step 3, okay, is getting, I'm going to go sub x equals 0 into equation to get the y-intercept. So the y-intercept is what you get when you make x equals 0. So that's going to be 2 times 0 plus 3 times 0 minus 7. That's 2 times 3 times negative 7. That's 6 times negative 7, negative 42. So again, I don't have the best scale here. Let's see if we can fix it. Make the point a little bit lower, negative 42. Okay, and now I'll take this away because now I know the coordinates of the y-intercept. So this is now at negative 42. Okay, and now I can really draw this thing. Let me just scroll up a bit. Oops. Sorry, I'm trying to erase this line. Okay, good. Now I can draw this end of the parabola. It looks like this. Okay, and I can draw. I can connect from 2 negative 50 up to the 7, and so really I have 4 points already, right? I got 4 points. I got this one, this one, this one, and this one. Can I get a 5th point? Where do you think the 5th point could be? Okay, so hopefully you see from the symmetry, the 5th point is easy to get. If I use that symmetry, it'll be right here. Okay, it'll be mirror image of the y-intercept on the other side of the parabola. So what point will this be? Well, I know that from the y-axis to the axis of symmetry is 2 units. So that means that from the axis of symmetry to here would also be 2 units. And so that makes it the point 4, negative 42. Okay, it's the mirror image of the y-intercept. And now I can connect the dots. And I have the entire parabola. Write the equation next to the end. This is 2, x plus 3, x minus 7. Okay, so how did we get the 5th point? Let's just scroll up and put that in. Oops. don't know why I'm not, so there we go. Okay, and so the fifth, so that we got the y-intercept, and then the fourth step is the mirror image of the y-intercept using symmetry. Okay, and now we have 5 quick points. So just to recap, I've got my x-intercepts are 2 points, so let me circle the points in orange. Okay, so my x-intercept, there's 1 point, there's another point, my vertex is another point, my y-intercept is another point, and the mirror image is the 5th point. So 5 points, and the equation is written in this form. Okay, please practice. Thanks for watching.